Hi folks, Russ here, and today we're in my crusty workshop having some more daisy lever gun fun. A while back, one of my subscribers asked about making some sort of tool to measure the differences in the springs, the mainsprings inside of these daisy lever guns. So I couldn't think of any way to rig up something from scratch. What I did is took the insides out of a hull from, it looks like a one of the older Daisy models here. And what I wanted to do with it, I think it was from a Golden Eagle or something like that, by the copper wash on the inside of the gun. You can still see quite a bit of that, especially if you look at the guide that came off the bottom and inside of the gun. The copper wash is still on there. Plating on the outside is all but eradicated. There were a lot of problems with this piece that would never go back to its original condition again. So I didn't feel too bad about using it to experiment with, and I've done several other experiments with it. What I wanted to do was come up with some way of accurately testing how much pressure it took to take the spring from its normal state inside the gun and put it into its cocking state, where it would actually engage the sear of the trigger. The only thing I could figure to do with this was measure how far the spring had to travel. That would give me an accurate basis for testing each one of the springs. I was able to do that by taking a normal little Red Ryder type gun, measuring inside of the gun, I don't know if you can see it too well, from the back of the plunger assembly to a given point, which I use the top of the receiver. And then whenever I cock the gun, put it into its cocked position, I measured from there to the back of the receiver and gauged the difference between the two. Well, it just so happens the difference between those two is 2 inches. And because these receivers are all built about the same way, I thought 2 inches would be pretty accurate. One of our prior videos showed how we could make some modifications on one of the older type Plymouth guns with a different cocking lever to be able to use the new cocking lever, and both of them engage that sear at the same distance. So 2 inches is just about right. Next, what I needed to do was make a way to eliminate some of the factors of friction. In other words, if you take a plunger assembly, a normal plunger assembly, you have this part which has to go through the abutment seal. You have this where there's a lot of friction on the compression sleeve inside. Some of these get worn, some are a little different than others. You have also a lot of friction along the sides of the plunger assembly itself whenever the spring rides up and down. So what I did here was to take and I'm going to pull this up over here. I took a standard plunger assembly and did some modification to it. I made a false plunger head, which has virtually no friction because it's very slight, very slight. It's smaller than the diameter of the plunger seal. And I made it so that it fits inside of this. If you can see that. The holes line up and so forth. So to test each one of these, what I did was I took a spring that I was going to test, I slid it on, let me assemble it here. Give me a second. See what I'm doing here. Now, if some of these are tight, you can actually use the caulking gun device with a washer that works out really well. Maybe I should, because I'm having a little trouble lining this up. There we go. Okay, and I take the plunger assembly as if this were a regular complete receiver. I slide it through until it hits that abutment washer. Now, the abutment washer that's in there is the original abutment. It's not really the washer, it's the abutment piece of steel itself. This simulates the approximate thickness of the rubber cup on the front of a normal plunger assembly. It's about the same when you go down from the washer to the top. So I take this, line it up inside. You can see it goes in really freely. I take my favorite little tool, compress the spring, this is a standard from a 105 buck, but they're all the same inside. I lay that in there, and I did change the rivet that was in here to this screw so that I could do some disassembly. And then, using a standard fish scale, I slide it in here. I mark the distance from here to 2 inches back, and as I'm pulling this in, where it intersects that line, I read the scale, and I get a reading of the different springs. One of the springs I used was a 22 coil. I think it's the one that's in there now. 22 coil with a diameter of 0.91. I read that on my micrometer, and it takes about 48 pounds of pressure to pull that spring back the 2 inches to where the sear would be. I had another coil, it's about 28 coils, 0.91 diameter. It takes about 50 pounds. So a couple of extra coils gives you a little bit more. And of course, this is by no means the most accurate scale, but it does show a difference between the springs according to the reading on this. Then I have a heavy duty coil over here, which is about a 28 coil, 0.95 diameter wire used on it. It takes a full 68 pounds to pull back. Now, what's the big deal with having more or less pressure from this point to the sear point? Well, if it takes that much pressure to bring it back, it's going to release that pressure at a higher rate. So the stronger the spring, the faster it goes in. The faster it goes in, the faster this builds up its pressure. The more pressure this builds up, the more follows through the air tube. And after this cue balls the BB out of the way, you get quite a bit of head pressure behind it to be able to propel that BB. Theoretically, and in many instances of practice, you get a faster performing gun whenever you use a stronger spring. So just in these little examples that I have here, this device will help us to gauge. Now, if you want something more accurate, I would suggest something that has a better tolerance to the national standards than this simple little spring-loaded thing with painted on numbers. They make some very good digital scales. The more accurate the scale, the more accurate you're going to be able to judge the differences in the springs. Maybe down to, the ounce rather than with this. And to make sure this scale wasn't totally out of whack, I took a 7-pound dumbbell and hung on to it, and it did come up just about 7 pounds on here. I took a lighter spring, one from a pop gun, and I got, in this gauge, 16 pounds of force that it took to pull. So to give it even a better test, general wisdom is that a gallon of water is about 8 pounds. So I took a 5-gallon bucket, I filled it to the brim, I balanced my scale hook on it, and you would think that a 5-gallon bucket, 8 pounds, would be about 40 pounds. And sure enough, with the bucket, the handle, and breaking the inertia of have it sitting on the ground outside, it actually left the ground at just over 40 pounds. So this scale may not be totally accurate to the exact pound, but it gives us a good idea, and it makes for a good comparison in our springs. Well, I hope this helps. So if you're trying to build a gun and you want to use lighter springs to make cocking easier, you know what to do. Look for ones with less coil and maybe less diameter. There are also differences in the coils, the way they're manufactured. The coils have to maintain a tempering through the entire distance of them to be accurate. Springs are never, ever without tension inside of the gun. First of all, whenever a spring is made, it's made to a certain standard, and it's tempered to a certain standard, and the tempering of the spring determines how accurate that standard is going to be. Then to put it onto the shaft, you have to compress it somewhat. So already it's under compression. Now people say to maintain the integrity of the spring, they don't like to keep the gun cocked when they're storing it. And that's probably a good thing, because as you cock it, even though it's only a 2-inch difference, as you cock it, you can tell that it's under even more pressure. You're compressing that spring even more. Here's an example of an old spring that came out of a gun that everything looked fine as long as it was riding on that sleeve. But then I got a glimpse of something that may have been awry. I pulled this off, and it has an arc. The more deflection you have in the center of the spring, the more friction you're going to have, and that slows down the spring action. That slows down the plunger. Some of these are minor. Some come off looking really good. And then I have others that look like a snake with arthritis. They just pop out of there, and they're all kind of twisted and having problems you just can't correct. You can try to straighten this out, and that might work for a little bit, but if something caused this to go bad here, other parts of the tension on that spring may also have an issue. So, all right, well, that's it for today, folks. Don't forget to subscribe. We really like having people look us up, and we like hearing from you. If there's any other things you'd want to take a look at, let me know, and maybe we can cover them here when we're having Daisy Lever Gun fun. This is Russ. We'll talk to you next time.